two particles here. This is of 1 kg. Here there is another particle of 2 kg. This is at x equal to 10 and this is at x equal to 20. Coordinate. Coordinate. Okay, Shyam, I'll tell. Just remind me once at the end of the class. I'll just quickly tell you. Okay? Fine. So, it is also provided that these started moving in this direction with 10 meter per second and these started moving. No, collision is not there. These started moving with 20 meter per second. Collision is not part of the exam syllabus. Krishna, very bad. Not good at all. You can understand. I'm just somehow continuing the classes. Okay. So, this is given in the diagram. Okay. And what they're asking, question is locate center of mass at t equal to 0 and at t is equal to 1 second. Correct? So the question is locate center of mass at t equal to 0 and t equal to minus t equal to 1 second. Fine. So now what to do? First of all, if you see this is at x equal to 10, this is x equal to 20. So these are x coordinates. It means what? It means origin is somewhere here to the left of this. Okay? All completed, Raymond. Today's class you are asking, Raymond, for today's class? Just beginning, first question you are doing. So now this is x equal to 0. This is refer origin. So origin x equal to 0, this is x equal to 10, this is x equal to 20. Okay. Now this template, whatever situation you are seeing here, this is at t equal to 0. So at t equal to 0, they are given the velocities, right? So the x initial coordinate of center of mass, x initial center of mass, we can write m1 x1 plus m2 x2 by m1 plus m2. m1 x1 is how much? 1 into 10 plus 2 into 20 divided by 3. That is equal to 50 by 3 meter. And this is from where? Today we are not, Kavita, not doing any topic. I'm just showing you few models which will make the revision process easy for you. Okay? So 50 by 3 meter, this is from where? This is from origin. This is from origin. So x initial center of mass is 50 by 3 meter from origin, approximately nearly equal to 17 meter. Okay? So it means if I show in the diagram, it will be nearly this much. So this is the center of mass. And by concept, center of mass will be closer to 2 kg now, because it is the heavier mass. So center of mass is closer to 2 kg and away from 1 kg. So at t equal to 0, my calculation is done. This is easy. Okay. Next, they have asked after 1 second, what is the location of center of mass? After 1 second, you have to locate the center of mass. Then, first you have to see whether center of mass is moving or not. If it is moving, in which direction it is moving. So, two things. One, we have to check whether center of mass is moving or not. Second, if it is moving, in which direction it is moving. So in step 2, this is my step 1. In step 2, I'll write V center of mass. Formula is M1 V1 plus M2 V2 by M1 plus M2. है ना? Now, if you look at M1 V1, 1 into 10, 1 into 10, rightward direction. Yes, I'm correct only. This one is moving back 2 kg. So I have to take this as negative, minus 2 into 20 divided by 3. So this comes minus 30 by 3 means minus 10 meter per second. The velocity of center of mass is how much? Minus of 10 meter per second. Clear? What is the significance of the negative sign? Significance is very simple. Significance is center of mass is traveling backwards. है ना? So we will write that center of mass is approaching the origin. Center of mass is approaching the origin. Yes, Srikar. Center of mass is approaching the origin. This much is clear to everyone. Please respond quickly. If you got this one, please respond. Quick response, please. If this is clear to all of you. Hannah? Good. Okay. Fine. Fine. Okay. Now, we have to find out at t equal to 1. When you have to find out t equal to 1. So look at the system now. I'll redraw the diagram once. This is 1 kg. This is 2 kg. Here is the center of mass. It is moving in this direction with 10 meter per second. And this is the initial coordinate of center of mass. This point is somewhere here, x equal to 0, and this is 50 by 3 meter. My point is, after 1 second, center of mass will come back by some distance. So I will check that this is the distance covered by center of mass in 1 second. So delta S by center of mass. What I will write? V center of mass into time. S equal to Vt. है ना? So V center of mass is how much? 10. Time is 1. That is equal to 10 meter. So this delta S is equal to 10 meter. And now center of mass is here at t equal to 1. So now what is the final location of center of mass? This much is the final location of center of mass. This much. So x final center of mass is equal to x initial center of mass minus v center of mass into t. So we will get 50 by 3 minus 10, that is equal to 20 by 3 meter. बोलो, crystal clear to everyone? चमक गया एकदम? No doubt whatsoever. Quickly respond. Please respond everyone. If there is any doubt, tell me. No doubt is there, no? Got the clarity? First respond, because after that I'll give you another question. है ना? ओके, ठीक है. Shall we move on for the next slide? Okay. हाँ. Okay. So let's go for the next question. This I am giving to you. All of you try this. Let's say this is 1 kg. Very easy question I am giving. This is also 1 kg. This is 10 meter per second. This is 20 meter per second. है ना? 20 meter per second. And this is at x equal to 5. No, 10 only you take. 10. This is at x equal to 20. And asking, locate, okay Shyam, I'll take one question. Locate center of mass at t equal to 1.5 second. Chalo, this is for you, do it. You have to try this one. All of you, please try. Quickly try this one. Yes. Okay, I got one answer. He's saying 15 meter. I'll check. Shyam, I think you've calculated the initial center of mass. Hi, yes. Yes. Gautam is saying 7.5. I think it's correct. I think. Let's see. Let's see. Okay, देखो. First of all, even if we have the formula, it is not important to apply the formula every time. Apply some brain. Two equal masses are there. Where is the center of mass? At the midpoint. Initially center of mass at the midpoint. Where this is at t equal to 0. Somewhere here is the origin, x equal to 0. So this is 10, 20 means this much is 5 meter. This is also 5 meter. है ना? So what about this distance? 15 meter. So x initial center of mass is equal to 15 meter. But they are not asking that. They are asking after 1.5 second. है ना? हाँ कौशिक, हाँ सृष्टि, I think correct answer. Good, very good. So now what we have to do? First calculate velocity of center of mass is equal to 1 into 10 minus 1 into 20 divided by 2 minus 5 meter per second. Again minus sign came. Minus sign came means C.O.M is approaching the origin. Okay, center of mass is approaching the origin. Very good. So then x final center of mass, standard formula is equal to x initial center of mass minus v center of mass into time. So 15 minus 5 into 1.5, that is equal to 7.5 meter. Correct answer is 7.5 meter. Good one. मजा आया? कर सकते हो इस टाइप का क्वेश्चंस? चमका ना? Good. All of you, perfect clarity is there. समझ गए? Please respond everyone. Any doubt here, please? Anyone? If it is there, quickly respond. Any doubt is there? No? Fine. So अब next we'll see two version of this same question. It can be little modified. Sir, how 5? 10 minus 20, that is minus 10 by 2, 5. है ना कभी तो? Clear? ठीक. So next we'll see a modified form of this same question. A little modification will be there, not much. Minus sign is showing the direction. Minus has nothing to deal with apart from direction. Okay? SSVD. Minus is only showing the direction, nothing else. Yeah. See. Now, let's say two particles are there. Mass M moving with 10 I cap meter per second. There is another, also equal mass, is also moving with 10 J cap meter per second. ठीक है? हाँ, yes, equal mass ना. So now they are saying that find the magnitude of displacement of center of mass in t equal to 1 second. And they have mentioned this is x equal to 10, this point is also y equal to 10. So they have started moving x equal to 10 and y equal to 10. तो ऐसी समझ के मैं जब भी कोई क्वेश्चन देता हूं, always rest assured that there must be a trick, है ना? How to find initial distance in previous question? Why not? Two equal mass, x equal to 10, x equal to 20. Center of mass is at the middle. If this is 10, if this is 20, what is the middle distance? 20 minus 10 is 10 meter. So half of 10 meter is how much? 5 and 5. Already the origin is 10 meter away from here. So from the origin to center of mass, 10 plus 5, 15. I did not apply the formula. Apply brain. Okay? Now, this one. Try this one. So, let us explain. It can be done in two ways. One is very boring way, laborious way, and another one is first method one. When they are at 10 and 10, they are moving perpendicular to each other. So what is x initial center of mass? Okay. So what is the x initial center of mass? This is moving along y, so for that it is 0. For this one, m into distance is 10 divided by 2m. So it becomes 5 meter. Similarly, y initial center of mass, that is also equal to same only 0 plus m into 10 divided by 2m. That will also come 5 meter. Are you getting? So that means initially The center of mass is here at this point. They are asking after 1 second. Logically सोचो. After 1 second, how much distance will be traveled by this one? 10 into 1, that is equal to 10 meter. Let us say the particle will be here. So for this coordinate will be 20. It was already at x equal to 10. Extra 10 centimeter moved, so 20. Similarly, for this also, it will also travel by 10 meter. So here also y will be equal to 20. So there is x final, that is y final. Now, what is x final center of mass? A 20 by 2, I am not doing now. 10. Y final center of mass, that is also 20 by 2, that is equal to 10. Okay. And then it will be somewhere here. It will be somewhere here. You have to figure out this distance. So delta S will be equal to root under of 10 minus 5 square plus 10 minus 5 square. That becomes 5 root 2 meter. ठीक है? But this is a nonsense method. Absolutely nonsense method. Why? I'll tell you. देखो, we can figure out velocity of center of mass. V center of mass vector is equal to m1 v1 vector plus m2 v2 vector by m1 plus m2. m1 is how much? M. Velocity is 10 I cap plus m into 10 j cap divided by 2m meter per second. M cancelled. How much it is coming? 5 I cap plus 5 j cap meter per second. Delta S center of mass vector, how much will be? V center of mass vector into time. Time is 1 second. So how much it came? 5 I cap plus 5 j cap meter. Now if you take the magnitude of this, delta S vector center of mass mod, how much is coming? 5 root 2 meter. This is method 2. Which one is better? Second one, na? It will save some time. Okay. Quickly note down. Yeah. Quickly note it down. Especially this one. To remember this. है ना? दिमाग चमकाना है एक्चुअली. फिजिक्स में यार, if you can apply the concept, there is nothing better than that. कंसेप्चुअली चीजों को सॉल्व करो, खट से उतर जाएगा. Is this clear to all of you? Is it done? Done, na? Correct. Shall we move ahead now? Next question. Shall we move ahead? Yeah. Chalo. Next देखो. This is a semi-circular disc. It's a semicircular disc, right? ठीक है. And the radius is given to be capital R. From this, this portion is cut out. Okay, this radius is r by 2 है ना. They are asking locate center of mass for the remaining portion. So this is not a full disk, semicircular disk. Challenging question, not easy. Understand how we will approach this. Working formula remains same. What is the working formula? R center of mass is equal to A1 R1 minus A2 R2 by A1 minus A2. Done, boys and girls. Working formula is fine. You remember mass cutting problems, है ना? Now, when you look at this diagram, as they have said, semicircular disk. For a semicircular disk, Y center of mass is given as 4r by 3 pi. Composite body. For a semicircular disk, center of mass is equal to 4r by 3 pi. Clear? Did you remember semicircular disk? Did you remember? Respond quickly. Fine. Correct? Now, come into this. No sham. When I am giving the question, be careful. Ha, Sikar. Yes. Chalo, we will do. So our center of mass is equal to A1. A1 is how much? Pi r square by 2. Half na? So pi r square by 2 into R1 is how much? 4r by 3 pi. Right? Minus A2 is how much? Pi by 2 into r by 2 whole square into R2 is how much? 4 into r by 2 divided by 3 pi. This divided by A1 minus A2. How much is that? Pi r square by 2 minus of pi r square by 8. If you calculate this one, this will come pi r square by 8. Check out everyone. Do the calculation and tell me how much it is coming. It's a wonderful question. Go to the calculation. Tell me how much it will come. Tell me the value, just value only. How much it is coming finally? Any one of you. Once you are done with the calculation, tell me the value simply. Shall I carry out the calculation? Chalo, we will do. So pi r square, pi r square, pi r square, pi r square. Cancelled. Even we can cancel pi r square by 2 only. It will be 4. Right? So how much this is coming? 4r by 3 pi minus this 2 cancelled. 2, 4, 2. So this is coming r by 6 pi divided by 1 minus 1 by 4, that is 3/4 चेक कर. So that is 6 pi 8r minus r 3/4. तो 7r/6 pi into 4/3 14/9. Final answer, r center of mass equal to 14r/9 pi. देखो, yes, okay Manas. See, these are based on the same concept. How simple formula it was, a1 r1 minus a2 r2. So what simply we have done for full disk, the moment they say it's a semicircular disk, see in what great way the problem can be changed. That's what you have to remember in the exam. Instead of disk, if they give semicircular disk, then there will be situation like this. Okay, Ray? Shall we move on? Will do. Shall we move on? Chalo. Next, देखो how easy this question will become. If I say this is circular disk and from this let us remove this segment. We will remove this segment. है ना? This portion is cut out. Now this will be easy because it is being said it's a uniform disk. Full disk it is. Correct? है ना? If you remove from this side, center of mass will be shifted on the upper side. Why? Because now the mass is more on this side and center of mass always stays closer to the heavier distribution of mass. So that means now how to apply the formula? R center of mass is equal to, formula is what? A1 R1 minus A2 R2 by A1 minus A2. है ना? See, now A1 is how much? Pi R square, full circle. R1, bigger center of mass. The bigger center of mass is here only. This is the origin. So that into 0 minus A2 is how much? A2 is pi r square by 4 because r by 2 whole square. You can check that if this radius is capital R, for this sphere, this radius is how much? R by 2. Right? Pi r square by 4 into. What about this distance? This is minus r by 2. Please be careful. R2 is, yes Vedasri, correct. This is minus r by 2. है ना? Yeah. Good Rupa. Divided by pi r square minus pi r square by 4. So it will come, please be careful, here in this case it will come plus r by 6. Why plus? Because I have taken it here, so center of mass will be shifted in the upward direction. Are you getting the idea? If it is cut from the this side, then to this side be shift hoga. If I have cut from the below portion, then center of mass will be shifted in this direction, na? And that is a positive y direction, whereas this is negative y direction. Clear? Why it is not minus r by 6, why it is plus r by 6? Did you get the clarity? Respond quickly. It's clear to all of you? है ना? Please respond, everyone. Okay? ठीक. चलो, clear एकदम, चमक गया? Good. Next, in this category we are going to do the last question. ठीक है? देखो. Now, semicircular ring. These are semicircular ring. This is of radius capital R. This is of radius R by 2. Its density is lambda. Its mass density is also lambda. So these two are kept like this. Then they are saying locate center of mass for the system. I'll wait for you. All of you, please do it. Let's see who can solve it. I'll give 2-3 minutes time to all of you. Try to do it. And in the meantime, I'll tell you the Y center of mass. Y center of mass for semicircular ring is basically 2r by pi. For semicircular disc, it was 4r by 3 pi. For semicircular ring, it is 2r by pi. Please don't forget. Try, all of you. Here in this case, what is the first concept you need to know? For a ring, mass is distributed along its length. For a ring, mass is distributed along its length. ठीक है? Okay. So that means that same R center of mass formula will write here L1 R1 plus L2 R2 by L1 plus L2. Wherever mass distribution was aerial, we take A1 R1 plus minus A2 R2 by A1 plus minus A2. If it is along the length, we'll take L1 R1 plus L2 R2 by L1 plus L2. ठीक है? अब देखो L1 is how much? Half length. Total is 2 pi r. Half length is pi r. R1, center of mass. How much? 2r by pi plus. This length is pi r by 2. Pi into r by 2. है ना? Into. For the smaller one, center of mass will be down along negative x-axis, है ना? ये ऐसे देखो, this is minus y, this is plus y, so this is down. तो down बोले तो minus we have to take minus 2 into r by 2 divided by pi. Why 2 into r by 2? Because its radius is r by 2. That is why 2 into r by 2. That divided by pi r plus pi r by 2. ठीक है? तो that means if I take pi r cancelled, pi r cancelled. So how much is coming? 2r by pi minus these two cancelled, r by 2 pi divided by 1 plus half means 3 by 2. So how much it is coming? If I take 2 pi as LCM, 4 minus 1 into r, 2 by 3. So 3 will be cancelled, 2 cancelled, r by pi. Check and confirm the result is okay. Requesting all of you, please confirm. Calculation is coming to be r by pi only. Please check. If there is any doubt here, feel free to ask. Respond quickly if you have any doubt. Respond everyone. Correct only na? R1 is 2r by pi. R1 is 2r by pi, Sikar. Check everyone quickly. देखो ना, pi r cancel ना, so 1 plus half. 1 plus half is 3 by 2 only ना, है ना मीनाक्षी? R by pi? Okay. अरे, that question was easy, Shyam Chai. This was very easy. What is that? That says that suppose if this is a disk, they have said this portion is cut and removed. So remaining is a semicircular disk. So what is the center of mass? 4r by 3 pi. ये कोई क्वेश्चन हुआ? Done this one, boys and girls. Quickly respond. Is this okay? No, Srikar, there is no removal. Addition. In this, addition is there. This portion and this portion are there, added. Two r by pi. So this one is for a semicircular ring. This 2r by pi is for a semicircular ring of radius capital R. समझे? है ना? गुड. ठीक है, ऐसे क्वेश्चन सॉल्व करना है तो इट विल टेस्ट योर अंडरस्टैंडिंग. परफेक्ट क्लैरिटी आ जाएगा. यू विल नेवर बी स्टॉप्ड इन एनी ऑफ द क्वेश्चंस. राइट? चलो, वन मोर आई विल ब्रिंग इन फ्रॉम motion of center of mass. This is the last question in motion of center of mass. We will not do anymore. We'll move on to some other segment. So there are two particles equal mass m and m. This is moving in this direction with velocity 4 I cap meter per second. This is moving in this direction with velocity 4 j cap meter per second. This mass also has acceleration 10 I cap plus 10 j cap meter per second square. For this particle, acceleration is equal to 0. Okay. Thank you. All the session will be useful, Sika, don't worry. Next, what I have to figure out? Question is path of the center of mass will be option A, parabola, option B, hyperbola, option C, ellipse, option D, straight line. है ना? Fantastic question it is. All of you try. Please try. Please try it once. Everyone, please try. Two particles of equal mass are provided. They are moving perpendicular to each other with equal velocities, 4 I cap and 4 j cap. But the particle moving along y-axis has acceleration too. The particle moving along x-axis doesn't have any acceleration. They are asking, what is the path followed by center of mass of this system? It's a marvelous question. Let's try, all of you. Okay, Rupa is telling straight line. Let's see. See, how will you do it? The best way to solve, first calculate V center of mass. V center of mass vector is equal to M1 V1 vector plus M2 V2 vector by M1 plus M2. So both masses are same, so M into 4 I cap plus M into 4 j cap divided by 2M. So how much will it come? 2 I cap plus 2 j cap meter per second. Respond everyone. This is clear? Nothing? Very simple na? Hai. Next, let us also figure out acceleration of center of mass. A center of mass. Same formula. M1 A1 plus M2 A2 by M1 plus M2. M1 A1 M into 10 I cap sorry plus 10 j cap. Second one, no acceleration, plus 0 divided by 2m. It will come 5 I cap plus 5 j cap meter per second. Okay? Up to now it is clear to everyone. Chamka sabka. Two very simple values you have calculated. Check it out quickly. है ना? Fine. Now see. I'll modify this result. Can I write like this? 5 by 2 into 2. I cap plus j cap meter per second square it will be. Can I write it like this? 5 I cap plus 5 j cap already, 5 by 2 into 2. It will turn back to 5 I cap plus 5 j cap only. Okay na? है ना? So is it coming that acceleration of center of mass vector is equal to 5 by 2 into velocity of center of mass vector? Respond. Are you getting this? Is it coming? Please respond everyone. मानस भाई, ये एम्स का PYQ है. Okay, fine. All right. So now, what is the condition? I am going to vector. Vector में क्या करना? If one vector is expressed as scalar multiple of the other, then the vectors are parallel. बढ़िया. So that means A center of mass vector is parallel to V center of mass. Acceleration and velocity parallel only happens for straight line, according to kinematics. Fantastic question. Is little on the tougher side, but conceptually very, very strong. Fantastic question. I mean, it might be a possibility that the entire question doesn't come. Might be you will not get the whole question in it, but you can get a fractional part of it. They will give this and will ask you what is the relation between acceleration and velocity. है ना? हाँ वैसे ही तो, वैसे ही. बट वो लिखना थोड़ा गलत इसलिए होगा क्योंकि वो वेक्टर इक्वेशन नहीं है ना अनश. दैट इज नॉट अ वेक्टर इक्वेशन. y equal to mx plus is not a vector equation. ठीक है. ओके फाइन. चलो, तो आई विल डू just one pulley question. Pulley means pulley related to center of mass, motion of center of mass. So let's say there is one mass 4 kg, there is another mass 8 kg. The system is released from rest. The system is released from rest. ठीक है? So then calculate acceleration of center of mass of the system. Very interesting question. It seems very easy, but it's not that much easy. Yes, Kavita, it is in gym. Thank you, Srikar. We are there to show you the brilliance only. है ना? Such brilliance are available only in Gosalite faculty members. Okay. Fine. G by 9, or Srikar is saying G by 9. We'll check. First, this will move up with acceleration A. This will come down with acceleration A. It is easy to calculate. A is equal to what? A is equal to m2 minus m1 by m1 plus m2 into g. 8 minus 4 divided by 12 into g. So it comes g by 3. So this is moving up with acceleration g by 3. And this is coming down with acceleration g by 3. But same. Kavita say that's why I have applied. No, I have written directly. That is a shortcut form. Acceleration of a system is what? Acceleration of a system is net force divided by total mass. दिमाग अप्लाई किया ना मैंने. Net force is how much? M2G is downward, M1G is the direction, the system is moving in the rightward, so M2G is greater than this, so net force is M2G minus M1G. My total mass is what? M1 plus M2. Right, Kavita? Got it? If I have to do from the force, I have to write two equations. क्यों करना? I can do in one line only. Correct ना? हाँ. So then acceleration of center of mass, what is the formula? M1 A1 plus M2 A2 by M1 plus M2, right? अच्छा, M1 A1 देखो, M1 A1 is up, moving up, so 4 into G by 3 minus, why minus? Because it is coming down, 8 into G by 3 divided by total mass is 12. So if I calculate minus 4G by 3, perfect answer. I think one answered, G by 9, someone answered. Very good, Rupa. Yeah. Acceleration of center of mass is coming minus G by 9. Is this clear to all of you? Did you get it? Acha, boys and girls, tell me, we have worked out those questions now. Meteor explosion, then center of mass will fall at the range. वो हो गया ना हम लोगों का? We have done those models. Projectile projected at the meteor, there is explosion, and the center of mass will fall at the range. Have we done that model? Done, sir, na? हाँ, ठीक है. Right? Yeah. So this many only. You practice these things. I think these are very, very nice questions. Extremely good questions. It will test your understanding. It will test you that how much conceptually correct you are. Question from module doubt. Okay. Which question, Rupa? Yeah. देखो. So we have started off with a brilliant question. बहुत कुछ कर लिया रे आज. We have done too many things. है ना? Okay. Shirisha, I think it will be shared. There is some family issue regarding the person who manages the WhatsApp group. So I think it will be shared. Don't worry. है ना? हाँ श्याम. See, apart from semicircular disc, semicircular ring, you can work out for the cone. Oh, easy है. Cone, है ना? 1:3 ratio for the cone, h by 4 from the bottom, h by 4 from the top, and that's it. Nothing else is required. Okay, ठीक. चलो. Based on audience demand, I will work out one gun bullet question. Only one question I will work out. Everything will be cleared. ठीक है? एक ही question work out करते हैं. सब clear हो जाएगा. It is there in the gym material also. क्या है? कि let us say there is a spring, and in front of the spring, a gun is firing the bullet. The bullet is moving with speed small v, mass of the gun capital M, mass speed of the gun is capital V. So the gun will recoil back. Why? Because before firing, I skipped this because I thought it is already been done in NLM. Before firing, P initial is equal to 0. So after firing, also P final has to be equal to 0 as per conservation of linear momentum. So what is the total momentum? Capital M into capital V plus small m into small v is equal to 0. So how much is capital V? Minus small m by capital M into V. ठीक है? Clear? अब see, I can write one line here. I'm writing that as the gun recoils back, as the gun recoils back, the spring will be compressed. है ना? The spring will be compressed. Correct? So till what time this will go on? Till kinetic energy of the gun is not zero. So that means for maximum compression of the spring, for maximum compression of the spring, क्या होगा? Kinetic energy of the gun will be equal to potential energy of the spring. A gun is coming back and the spring is getting compressed. So total kinetic energy of the gun will be converted to spring potential energy. So you imagine that spring is compressed by a distance d. So can I write from here? What will I write? I'll write half capital M into capital V square is equal to half k into d square. है ना? अब half of cancel. Capital M, capital V is how much? Minus small m by capital M into small v whole square, that is equal to kd square. In that particular question, they have asked what is the velocity of the bullet. So I'm directly writing the answer. You will get root under of k capital M d by m. This will be the answer. इजी है रे भाई, ये सब आप तो यू हैव डन दिस इन न्यूटन लॉज ऑफ मोशन. तो यहाँ पे 2 टाइम्स रीडिंग का कोई मतलब नहीं बनता है ना. हाँ, ओके फाइन, क्लियर एवरीवन, पक्का? ठीक है दोस्त, चलो आज इतना ही. आई कांट कंटिन्यू, है ना. अगेन विल मीट ऑन द नेक्स्ट डे, प्रोबेबली आई विल बी फाइन. Okay, Rupa, just any particular expression to segment where we have to ratio of kinetic. Are Rupa, this is easy na? Very easy. What do you have to do, Rupa? Initial momentum 0, final momentum is m1 v1 plus m2 v2, and then ratio of kinetic energy is what? Half m1 v1 square divided by half m2 v2 square. Use these two equations. है ना Rupa? Chalo. So I will give you this keyword that is most important for you. Yeah. Okay. Today this much only. I'm feeling some serious sick, तो नहीं हो पा रहा है. Okay. हाँ. So this is the QR code. Okay. Love you all. Take care. We'll meet in the next class. ठीक है ना? Bye bye. Thank you so much. Thank you. Thanks to all of you. Okay. Right. Bye. Bye bye.